Hello everyone, my name is Vanessa Lagos. I am a second-year PhD student under Dr. Hans Stein, and today's presentation will be about the effect of formulating diets based on a ratio between STTD calcium and STTD phosphorus and the inclusion of phytase on the calcium and phosphorus balance of growing pigs. The requirement for calcium is expressed as total calcium due to the lack of data for the digestibility of calcium in feed ingredients. But research has provided values for the standardized total tract digestibility of calcium in different calcium-containing feed ingredients. This has allowed for the formulation of diets based on standardized total tract digestible calcium or STTD calcium. So now we can estimate and formulate based on a ratio between STTD calcium and STTD phosphorus. A number of experiments have been conducted to determine STTD calcium to STTD phosphorus ratios using different body weight groups, from 11 to 130 kilograms, and results indicated that if the concentration of STTD phosphorus is at the requirement, these are the ratios that should be used to maximize growth performance. These values have been already validated as described in the previous podcast. Requirements studies not only look for maximizing growth performance, but also bone mineralization and in some cases calcium retention. And it was concluded that the ratio to maximize growth performance is lower than to maximize bone mineralization, and a couple of studies demonstrated that the ratio that maximizes calcium retention is even greater than those that maximize growth performance and bone mineralization. So because the objective is to maximize growth performance, we evaluated the effect of using values to optimize growth performance on bone mineralization, but we still don't know if there is a negative effect of using those values on calcium retention. Another important finding from these studies is that excess dietary calcium negatively impacts the apparent total tract digestibility of phosphorus, which may result in a phosphorus deficiency that will decrease average daily feed intake of pigs and therefore growth performance. This is important because of the difference between calculated and analyzed values for calcium and phosphorus in diets. In 2016, almost 800 commercial diets from the poultry and swine industries were collected and analyzed for these two minerals. It was found that there is an excess of 0.08 percentage units of phosphorus, which is an acceptable value, but for calcium the excess is 0.22 percentage units. This will definitely compromise growth performance of pigs. So with this being said, I will move into the objective of the experiment, which was to test the hypothesis that formulating diets based on a ratio between STTD calcium and STTD phosphorus instead of total calcium and STTD phosphorus will not affect calcium retention, but will increase the efficiency of phosphorus utilization. Moving into the materials and methods, 40 pigs with an average body weight of 59.4 kilograms were used. There were 2 periods of 11 days, and 4 diets were formulated based on a 2x2 factorial design. These diets were based on corn and soybean meal and contained 0.22% of phytate bone phosphorus. The first main effect was requirement estimate, total calcium or digestible calcium, meaning a ratio between STTD calcium and STTD phosphorus that maximize growth performance of pigs from 50 to 75 kilograms, and the second main effect was phytase inclusion, either 0 or 500 FTU of quantum blue. To understand how the diets with phytase were formulated, we assumed a release of 0.11% STTD phosphorus and 0.16% STTD calcium by phytase in the total calcium diet. For the digestible calcium diet, we assumed the same release of STTD phosphorus by phytase, but the concentration of STTD calcium in the diet was estimated by using calcium digestibility values of feed ingredients from phytase diets. Then the calculated amount of STTD calcium released by phytase in this diet was 0.17%. Finally, there was a total but separate collection of feces and urine. Now let's take a look at the results for calcium balance. Here I will start setting up this slide. Blue bars represent diets without phytase, and orange bars represent diets with 500 FTU of microbial phytase. Lighter colors indicate diets formulated based on total calcium, and darker colors indicate diets formulated based on digestible calcium. For calcium intake, there was an interaction between requirement estimate and phytase. Pigs fed diets without phytase had greater calcium intake if diets were formulated based on total calcium compared with digestible calcium. And this is a result of the concentration of calcium in the diet. Now, in the phytase diets, there were no differences in calcium intake between calcium requirement estimate. Here we can also observe that pigs fed diets formulated based on total calcium had lower calcium intake if phytase was used. And this is because the calcium releasing effect of phytase was taken into account. For calcium excretion in feces, we observe a similar pattern as for calcium intake, an interaction between main effects and a reduction in the amount of calcium in feces in the non-phytase diets based on digestible calcium. In terms of digestibility, I will start with the results for the amount of calcium absorbed per day. Here, an interaction between requirement estimate and phytase was also observed, and the response to the dietary treatments was the same as for calcium in feces, which is a result of the amount of calcium ingested by pigs. For the apparent total tract digestibility of calcium in the diet, there was no interaction between main effects, but diets with phytase had greater calcium digestibility than non-phytase diets. And this is because phytase not only releases phosphorus, but also calcium that is bound to phytate. Now, if we look at the total calcium diets, the apparent total tract digestibility of calcium was greater when phytase was included, even though pigs absorbed less calcium. And the reason is that in this diet, pigs also ingested less calcium than pigs fed the non-phytase diet. Now we are looking at the concentration of calcium in urine, and we can clearly observe that there is an effect of requirement estimate. Regardless of the inclusion of phytase, pigs fed diets based on digestible calcium excreted less calcium in urine than pigs fed total calcium diets. Finally, for calcium retention, there was an interaction between main effects for the amount of calcium absorbed by pigs. Pigs fed total calcium diets absorbed less calcium if phytase was included. However, regardless of the inclusion of phytase, there were no differences between the two requirement estimates, which confirms our first hypothesis. In terms of the retention of calcium as percentage of intake, no interaction was observed, but the two main effects were significant. Calcium retention was greater if diets were formulated based on digestible calcium or if diets contained 500 FTU of microbial phytase. And here again, we observe a greater calcium retention as percentage of intake when pigs retained less calcium, which is also a result of the lower amount of calcium ingested. Now we're going to review the results for phosphorus. In terms of intake, there was an effect of phytase. Pigs fed diets with phytase had less phosphorus intake than pigs fed diets without phytase because in the phytase diets, the concentration of STTD phosphorus was reduced by 0.11%. And although there was a tendency for pigs fed digestible calcium diets to consume more phosphorus than pigs fed total calcium diets, within each phytase inclusion group, diets were formulated to contain similar concentrations of phosphorus. For phosphorus excretion in feces, we observe a similar pattern as for phosphorus intake in terms of the effect of phytase, but no effect of requirement estimate was observed here. Now we are going to look at the data for phosphorus digestibility. This is the amount of phosphorus absorbed per day. For this variable, there was an interaction between requirement estimate and phytase. For the non-phytase diets, pigs fed diets based on digestible calcium absorbed more phosphorus than pigs fed the total calcium diets, and no difference in the amount of phosphorus absorbed was observed in the diets with phytase between the two requirement estimates. For the apparent total tract digestibility of phosphorus, we also observe an interaction between main effects, and we observe a similar pattern as for the amount of phosphorus absorbed. Diets without phytase based on digestible calcium had greater apparent total tract digestibility of phosphorus than diets based on total calcium, but no differences between requirement estimates in the diets with phytase. But if we look at the diets without phytase, we can observe what I was mentioning in the introduction about the negative effect of high calcium in the digestibility of phosphorus, which is also observed in terms of the amount of phosphorus absorbed by pigs. For the concentration of phosphorus in urine, we also observe an interaction between main effects. Looking at the diets without phytase, we observed that pigs fed diets based on digestible calcium excreted more phosphorus in urine compared with pigs fed diets based on total calcium. This indicates that yes, these pigs fed diets based on digestible calcium absorb more phosphorus, but because the concentration of calcium in the diet is low, phosphorus cannot be used for bone synthesis and therefore will be excreted in the urine, which may indicate that in this diet we don't need to include as much phosphorus as we think, but more research is needed to validate this hypothesis. For phosphorus retention, expressed as grams of phosphorus absorbed per day and as a percentage of intake, there was no interaction between main effects and no effect of calcium requirement estimate, which rejects our second hypothesis that formulating diets based on digestible calcium increases phosphorus utilization. However, there was an effect of phytase inclusion in both variables. Pigs fed diets with phytase retain less phosphorus than pigs fed diets without phytase. This was unexpected and may indicate that in order to release 0.11% STTD phosphorus, more phytase is needed. For phosphorus retention as a percentage of intake, we observe greater values with phytase because these pigs consume less phosphorus. In conclusion, pigs fed digestible calcium diets did not retain less calcium than pigs fed total calcium diets. Calcium excretion was reduced in urine of pigs fed diets based on STTD calcium compared with pigs fed diets based on total calcium. In diets without phytase, formulating based on digestible calcium increases the apparent total tract digestibility of phosphorus, and there was no effect of digestible calcium diets on phosphorus retention. Finally, I would like to acknowledge AB Vista for the financial support and all the members of the Stein Monogastric Nutrition Laboratory. If you want to find more information about this topic or more topics, please visit our website at nutrition.ansai.illinois.edu. Thank you for listening.